Hi, I'm John Hofford, and this is Nicholas Rode. We both work on constraint layout and the Android Studio design surface. Nicholas will sort of give us a little introduction to the whole thing.
So hi, everyone. So we're going to talk a little bit about Android Studio in general and a little more as well about constraint layout. So quick summary about what's our goal here, right? As far as Google developers, what we want is really to make your life much better, right? We want to listen to what you have to say, any feedback, any ideas, requests, bug, anything. We really are, looking into that. And we're trying to move fast. Since last year at I/O, we released the stable version of Android Studio 2.2, 2.3, and we are now working on 3.0. And I strongly encourage you to test 3.0. There is a lot of improvements in the layout editor, notably. And specifically for the layout editor, for the visual designer in Android Studio, our goals are relatively simple. Basic one, we want you to be able to visualize your layout. Yeah, I know, it's called a visual designer. We want you to be able to create those layouts very easily. And all of that being efficient. We don't want you to lose your time for no reason. And on a note, John.
OK, so we want to just give you a brief overview, the lay of the land of the designer, to give you an idea of how it all comes together. So one of the things you can do is in dark killer mode. I'm sure a lot of people like dark killer mode. And you could go back to the other one. Now, we have on the left-hand side the palette. That's basically where you can just drag and drop your widgets onto your design surface. Then the component tree. Then comes the inspector, and we'll have much more about that later. Then the core design surface. And there's a toolbar. We also have a right-click menu. So a lot of people kind of forget that there's a right-click menu. If you select an object, you can click on it, and right-click, you'll get useful actions associated with what you've selected. The other thing that you can switch to is blueprint mode. You could also switch to 2 screens at once. The blueprint mode is kind of a blueprint. It's a rough outline, a sketch of your UI. The design surface is actually being rendered in Layout Lib, which is a sort of emulator of Android. So one of the things that we also can do is use the designer in the XML editor mode. So if you are in the XML editor and you press the preview, you get essentially a full design mode right there. Notice if you select, it'll actually navigate you to the right element in the XML. You can switch to see design or blueprint. You can also expand it a little bit, pull out the palette, and you could actually just drag an element right there on the screen. Notice it actually created the XML at the bottom. And in fact, if you edit the XML, in this case, I'll just delete the XML, it goes from the design surface instantly. So you get a real-time feedback in both directions, simply like that.
So that was just a brief introduction, just to give you some of the concepts, some of the vocabulary we are going to use in that talk. And hopefully you've been already familiar with this UI. If not, again, give it a try, specifically with 3.0. Let me cover constraint layout now. So constraint layout is a library we announced last year at I/O in this very room. And the general idea is to provide something that gives you all the flexibility and the power to create any type of layout that you want, with a strong emphasis on having flat layouts. If you have flat layout, meaning you don't have a nested hierarchy of view in order to create that layout, there's a lot of advantages. One often repeated advantage is performance. Indeed, with nested layouts, you could have corner cases where there's an explosion of computation necessary. So if everything is flat, you tend to win in performance. So that's one reason. The other reason, which I think is actually more interesting, is you got a lot more flexibility. It's much better if you want to animate content. It's much better if you want to modify the content, upgrade it, modify it, etc. The other big thing with constraint layout is it's the same team that works on constraint layout and on the layout editor in Android Studio. So it's deeply integrated from the very beginning, which means that we have some features in constraint layout that helps creating a great UI designer, and vice versa. We have some features in Studio that allows you to create much better and much more efficient layouts with constraint layout. It's also an unbundled library, which means we can push any version anytime. And in fact, we just pushed a new version like 5 minutes ago. And it's compatible with basically every device. So, quick recap on the 1.0. Last year, when we announced the 1.0, we did a long series of alpha releases, beta releases, and basically 17 releases since last year. When I told you we are trying to move fast and iterate quickly, that's what we do. We did the final release of 1.0 in February. Lots of performance increases, particularly if your only try with constraint layout was last year. Definitely give it a go. A bunch of new features as well that we'll cover. And it's the default layout now in Android Studio. So when you create a new screen, by default, we'll put constraint layout where before we used to put relative layout. And of course, Studio is very flexible. If you want to change that, you can. But we really believe that it's a great layout to start your screen with. And that's what we want to encourage you to do. And all of that really should not have been possible without the involvement of the community. There's been a flurry of articles, talks, video on YouTube, leading to widespread adoption of the library. There's also a new community-based constraint layout website that is launching this week, and you should check it out. So 1.0, what did we have in terms of feature? What did we show you last year? Well, and what did we add in the meantime? So we had the original idea of having relative positioning. You can set up your layout so that one button is going to be positioned relative to another element. Very similar to relative layout, with a couple of interesting tweaks. We also added a center positioning. So if you create constraints in between two targets, your element will be centered, and you can actually modify that. It's not just center, you can apply a bias. So think about it as being able to build much more flexible, reactive UI that will position themselves not simply in terms of an exact dimension. We also introduced the concept of helpers object, like guidelines. And the idea with guidelines is that it lets you create a UI in a much more natural way, particularly if you come from a design background or if you are working with designers. They always think and create their layout in terms of, they call it many names, guidelines, key line, red lines, basically vertical and horizontal lines to make sure that everything is aligned correctly. Well, guidelines in constraint layout is just a first-class concept that you can use and create your layout with. But ultimately, on the device, it just results in the right settings for the layout. We also introduced chains, and that's a relatively late addition in the 1.0 release cycle. Think about it as being able to position a group of widgets as a group, so to, for example, spread them apart. The interesting thing compared to previous layouts on Android is that it only works in one axis. So the other axis is not constrained by a chain. Finally, we introduced ratio. I'm sure a lot of you had to re-implement a custom view just to implement a ratio. Well, we just added it in constraint layout from the get-go. And last but not least, we introduced constraint set. The idea with constraint set is that now we have a layout that is flat. There is no hierarchy necessary to create your layout. In a sense, you end up with a bunch of widgets at the same level. And we apply in order to create the layout, to get the result that you want, we apply those constraints. So constraint sets, the idea is simply that we gather all those constraints and put them into that object, into a constraint set object. So you can create a constraint set that embed all the constraints of your layout. You can create it from a layout file, from a live view hierarchy. And the fact that you can do that is actually really, really powerful because, and just to give you a simple example, you can simply just toggle one set of constraints with another one. So it's very easy to tweak your UI at runtime. And even more, you can specify and create your layout in the comfort of the layout editor graphically. And at runtime in your program, you can decide which layout you want. So this is a very powerful concept, and we'll come back to that. And finally, today, we just released 1.1 beta 1. And it's available on Maven. So it should be very easy for you to integrate in your workflow. So what did we add in 1.1? We added first the concept of barriers. And a barrier, in essence, is a way to say, just take on a set of widgets, take the maximum or the minimum of an edge. And that allows you to create a lot of UI that previously, with Constraint Layout 1.0, would have been tricky to do. We also added another helper class that's called the group, which for now is relatively limited, but we have some ideas on how to improve it. But the concept is basically you can have a set of widgets that are stored into that group. And you can set, for example, the visibility of the group. So you don't have anymore to maintain yourself a list of widgets just so that you can toggle their visibility in one go. You can just specify that in XML. And any visibility state on the group will basically be applied to the element in the group. We also have a new concept, the placeholder concept. And we'll cover that in more details later. But I think you'll like it. And finally, we added a couple of tweaks in the way we deal with constraints on dimensions. So if you ever wanted to create a view whose width was 30% of the screen, you could do that, but it was a little complex with guidelines, because guidelines allow percent positioning. But now you can just do it simply directly on the widget. And now we're going to cover a little bit of the new features in Android Studio itself.
Yeah. So essentially, to give you a kind of more detail inside of Android Studios, we have a set of tools. Some of them we'll talk a little bit more about later, but we have a series of them that are alignment type tools and arrangement type tools, and we have some stuff to add guidelines, and we'll see more on those. Here's also the right-click menu, which is actually a lot of them are existing tools. Now, here's a little example of what you can do with the tools. So in this particular example, I create a chain, I center align all of them, and then I use the inference to automatically connect them. So in 3 clicks, I have just essentially made like a top layer layout. Now, one of the other things that we've done a lot of work on is the inspector. Those little pluses you see I'm clicking on, they automatically cast a ray and connect to the adjacent surface. So it's a quick, handy way of just making the connections without actually having to drag out little lines. It can really speed up a lot of connections. And then I'm playing with all the other features of the inspector. I can change the bias. I can then go and kill connections all over again. And they both work together. So I just move it back over, and the loop starts all over again. The inference, you saw me do a little bit of the inference before. It's essentially based on a probabilistic model where we try to estimate what is the most likely thing it would want to connect to. If they're aligned above each other, it's more likely to align that way. If it's directly on the center, as the little icon is it will want to connect it. One of the cool things about it is that you'll notice I can make connections and then use inference to finish it off and essentially complete my UI. So the ones that I care about a lot, I can do by hand, and inference does not currently create chains or some of the new widgets that we talk about. They don't operate properly with some of the newer design features. But as those features become stable, I will work on putting them into the inference engine. So here's an example. It inferred, and as you can see, it detected that it was centered and attached there. It changes some things from wrap content to 0DP, things like that. It just tries to fix it. Now, one of the other things to remember here is it's not a beautifier. It is not going to align things for you and arrange things. It tries very hard to keep exactly where you put things. So I've seen a few cases where people just sloppy put things on the UI and then hit inference and they get bad results because it's not organized. So just remember to do that when you're thinking about it. One of the things that we like and we use is the inspector. You just saw me use it. There's another mode that you can get if you hit the little arrow at the top, which is this, which is all the constraints. That's kind of a pain to use, quite frankly. So we've been working on something to try and make that a little easier and how you would use it and how you would interact with it. And we call it, internally we call it slice. So imagine whenever you have a layout, you will actually have, associated with the layouts, you'll have a dimensions, a strings file, a few files. And the information you're trying to work with is mapped across all of these different files. So it becomes this sort of hopping around game where you're trying to figure out, I've got to go and adjust the dimensions here. I got to go and set the string in this file, and I have no easy, simple navigation. So if we can take the selected object in the layout, the dimensions that uses, the strings it uses, and all the other things it's referring to, and we sort of combine them into one user interface, it appears on the right, and we gave it a look that is kind of like an XML file. So if you're used to the XML, you'll kind of understand what it does and how it works. You can sort of see the files that are coming from all the other parameters. For example, the drawable is a picture of me. The values is some number. And in fact, you can go edit and even create new elements directly in that user interface. So it's a quick, fast way to work within the designer and do all the other little things you would like to do typically.
So let me talk a little bit about the tools attribute. So the idea with showing you all of this is also that you could, of course, use all those layouts in XML, right? I mean, they are normal Android layouts. You can use the old layouts. You can use constraint layout. Everything is perfectly usable in XML. But the idea, and this is what we strongly believe, is that with the designer, we've got a great opportunity to really make your life easier. I think you could see with some of those tools that we presented, doing the same thing in XML line by line is certainly doable, but I think you'll be much faster by using those tools. So the tools attributes, it's something you may know already, right? See, the general problem is that we have something in the editor that's not executing your code directly. So sometimes what we show you in the layout editor is not going to be exactly the same as what you have on your device. So because, for example, some of it is just determined by your program. It's things computed at runtime. So we had this idea of having tools attributes where you can specify behavior that will only be applied in the layout editor. So those attributes are not going to be there when you publish your application, when you push it on a device. They are just stripped out. But in the designer, that allows you quite a lot of flexibility in how you want to render things. So we got like showing, for instance, is pretty useful. List item, to set up something in a recycle view and things like that. So that's this generic problem, right? Of how do we want to show layout when we don't really want to execute the code. If you try to drag a recycle view or a list view in the layout editor, that's probably what you saw, because we automatically generate a default adapter that is pretty limited, and by default, that's what you see. This is probably not how your application looks like. So if you have some content, let's say I created a row, you can specify it, and you'll be able to see that being replicated. Better, but clearly not what your application is going to look like, right? Of course, you're going to have different data. So, and that's where sample data comes in. You could specify new attributes, and this is going to be available in 3.0, where by default we have pre-baked attributes, like for example names or phone numbers, and you'll be able to reference that instead of other attributes, and that will be replicated in the designer. So think about it as a way to very quickly see how your layout is going to look like without having to program anything. We actually do more than just that. We have a new sample data folder in the project that you'll be able to create. You could specify things like colors, and that's trivial. Just create a text file, put the colors on each line, and that's it. Every time that you reference that element, we will pull the next color, and we'll just loop. So you can very quickly get something like that. And you have more sample data capabilities. You can display lorem ipsum, date in a specific format, colors. You can even specify an entire JSON file if you want to use more structured data. So we got baked-in data types. Oh, sorry. Clicker. Baked-in data type. The JSON files, as I said, if you want to have more structure. And if you have any resources into that sample folder, you can reference it, and we'll pick them. So if you want a collection of images, for instance, you put them into a folder, and you reference that folder. We'll pick the next one. And let's go on some more advanced examples on constraint layout. So you may have seen, in your practice, a problem like that. I have some text on the left of my button, and I want that text to grow, but no more than what the button allows. And I want everything to be centered left. So the way you would do it in constraint layout, and it's a little, it can be a little tricky, but fundamentally, we create a chain, make the text being resizable, and it will automatically apply the constraint, so it won't go further. And so that's just a quick example of how you can use chain. It's not just, oh, I want to spread widgets apart. You can do much more complex and powerful combinations. So there's another example as well about the gone behavior. So by default, when you set a widget to gone, we resolve it as a point. So in that case, my center button gets collapsed basically as a single point. And that behavior is, looks fine to me. That's probably what I want. Sometimes it's not going to work the same way. So if I do that on the first element, everything collapses to 0 again, the margin included. And then the rest of my buttons are moving. So that we have another attribute that you can specify when the object you connect to is gone. And in that case, we'll use those values for the margin. So the second button had originally a margin on the top of 0, and now has a margin of 32. Only if the first element is marked as gone. And let's talk a little about placeholder, which is a new addition in constraint layout 1.1.
Okay. Yeah, so this is new to 1.1. Essentially, what it is you can create a virtual view and set its content to another view within the constraint layout. So in this simple example, it's grabbing whichever one you clicked on, whichever view you clicked on, and warping it up to the top of the screen. if you look at the text, it might look a little strange if you're not familiar with Kotlin. Check out Kotlin tomorrow. That's the total length of the code inside of the Kotlin file. So the animation you're seeing on the right is completely being generated by the code you see on the left. Nothing else is being used on an XML file. So as you can see, it's randomly switching. But the fact that you can actually have a placeholder, a place where you can move a widget, may seem like, OK, what else can you do with that? Well, if I design a placeholder-based UI with a merge tag, essentially, I've defined an in-constraint layout. Make sure to use the parent tag if you want to see the UI while you're doing it. It essentially gives you a fixed layout, which you can then use in another file. So in this case, I've decided to have one placeholder that's going to be my top image, a big image, and then a second placeholder that's going to be my action button. But I can actually make a second placeholder with now using, for landscape mode. And this one, I arrange it a little bit different. I use a slightly different set of constraints. And now in the main layout, I just declare the two UI elements and include the placeholder, the template. Essentially, it produces a template that decides on how you do your layout. And because there are, in fact, two of these templates, one in different ones, when I rotate the screen, it would actually take the other template. So now I can lay out my views and separate out the layout from it. But I can actually do more than just that. One of the things that you can do with this structure is, what if instead of the image button, the second image button, I could decide to put an entire include file with something else in it. So in this particular case, I have, I don't know why that. In this particular case, I have an entire include with a bunch of different layout elements, and it's actually being warped into that space. So it's a constraint layout within a constraint layout, so it's nested in that context. But this is a very simple and almost stupid example, but you could imagine where you decide how you want the top and the bottom, the left and the right, and behaviors, and lay them out and design them as templates. And then when you're ready to produce your main stuff, you just go and do it in a completely separate file. You can have designers help you design templates, things like that. One of the things that we wanted to do with constraint set, and I'll talk a little bit about how you use constraint sets, is you can separate the views completely from how you do the layouts. So essentially, another way of doing things is to encapsulate your entire layout as a separate constraint set, and then you apply it to a layout. So you might kind of wonder, what would you want to do with that? Well, you can switch between two constraint sets on the fly. No views get reloaded. It's not like switching a layout. You're actually just moving the widgets around by applying different sets of constraints. So in this example, I create two constraint sets. And I grab a constraint set from a layout file, and I put another layout on the screen with set content view. Then I actually get that one and grab its constraint set in constraint set 2. Now, to switch between the two constraint sets, all I have to do is call the constraint set and apply to the constraint layout. And that will allow me to switch. So I can produce lots of clever animations that way. So one simple example is if I have a dialog, and this is a normal constraint set with my picture on it. And I can do another one in landscape. Now, instead of creating two separate layouts and inflating them when you rotate, you can take over the rotation yourself, and you can perform the constraint set switch yourself. And that way, you have a lot less going on during rotation. So if you have an app that likes to rotate a lot, you can do it that way and save some speed.
Well, the other thing that's important to keep in mind with a constraint set is, and this example of rotation is interesting. Of course, you can use the normal system on Android and let the resource being loaded at runtime. The thing with constraint set is that you're actually in complete control of when you create the constraint set. So often in mobile, it's not so much about trying to not do the work that you need to do, because you need to do it. So sometimes if the work is costly, you still have to do it. It's more a matter of trying to find the right time on when to do it. And to me, that's what constraint sets allows you to do. You can basically pre-bake all those constraints and load them before, and so you don't have to incur like a stutter or anything like that, because suddenly you have to pull the entire set of resources. So constraint set is also pretty useful when we want to do motion in general. So one advantage of constraint layout and this focus on trying to keep a flat hierarchy is that there's no clipping issues. You can think about it as a scene graph. You just have all the different objects, the visual objects you want to show on screen, your buttons, your images, and etc. And you can think about constraint set in some ways as a keyframe. And the way you would do that, if you remember that slide that we just saw, you only need to add one line, and that's all. And that's simply using the Android transition framework that also is available in the support lib. And that will automatically animate any type of layout changes. That also would apply even on the individual view, right? So in that example, I have, clicker is not happy. In that example, we have a layout that's set with the normal constraint layout, but I can change the parameters of an individual view. The layout will automatically resize accordingly to the constraints I set, and Transition Manager will animate all of that. So you can do kind of complex behavior like that very, very easily. And the code itself is really trivial. You could do a lot further than that, And that's another example. You could create one state of your screen in one layout, create a second state, basically, and load that from constraint set. Apply that at runtime, and the transition framework will just do the rest. What's really cool is that you do that graphically. You don't have to try to figure out how much you need to do, what's the dimension. No, you have the immediate result on screen without having to do a round trip to your device. And that was purely in constraint layout. But constraint layout can be also used by leveraging the existing framework and the existing widgets in the framework. So here, this is just a nav view, that the one used in the draw layout. But I can simply reuse it into a constraint layout here. So here, this is a simple subclass that's applied that. What's nice is, and I encourage you to think about it in the link to the concept of placeholders, is that you could basically define a set of generic rules on how your UI behave. And so constraint layout becomes something a lot more than simply I just want to position my buttons and how they interact with each other. It can become more about how the entire UI moves around. And of course, you can apply that with your custom widget if you want. That's as simple. So here's another example of the whole constraint set / transition animation. So we define two states, like the previous examples. And you see like the shadows are applied, the elevation changes, and all of that is done graphically. The only problem with this animation is that it's a little stale. I mean, it doesn't do anything special. There's no movement. But we could do a lot more than that. And with custom transitions, you could simply define whatever you want. So recently, there was a physics library being released, you could easily create your own custom transition, plug them into the system, and do whatever you want. I would not encourage you to replicate this particular UI. This is a test example. But just to give you the type of flexibility this approach can give you. And on that note, I think we are done. We have a few minutes for Q&A. And please do file bugs, feature requests. You can contact us pretty easily. The documentation of Constraint Layout is available online as well. And as I said, we just released 1.1. Please give it a try.